Hello everyone, I'm Ayush Dongre from Cyber Physical System branch in VIT Chennai. My registration number is 21BPS 1508. The topic which I'll be presenting you today is application of automata theory in networking. So, what is an automata? Automata is a simple system which works by itself without any human interference. uh, the study of abstract machines and computational problem that can be solved using these machines is called automata theory. The abstract machine is called the automaton. There are two types of automata. One based on the number of states. The states can be finite or infinite. If there are finite number of states, then we have deterministic finite automata and non-deterministic finite automata. And if we have infinite number of states, then it will be a push down automata. Now, these are all the languages in which conversion is possible from one to another. Each language has its own significance. We can convert regular expression to other languages, then NFA, epsilon NFA, and convert it to F NFA, then DFA, and further on. All of these have its own significance. Each modern automata theory plays an important role in several applied areas. Finite automata are used in text processing, compilers, and hardware design. Now, context-free grammar (CFGs) are used in programming languages and artificial intelligence. uh, CFGs were used in the study of the human languages originally. Now, applications of automata theory in networking. Until now, we have discussed various fields in which the automata theory is used. Now, network use some specific protocols to transmit and receive data. These protocols used are error control, flow control, and bandwidth limitation. Now, to solve these problems require the definition of one or more communication protocols, that is, shared conventions for the transmission of data in one direction and acknowledgements in the other direction. The Internet of Protocol stack has five layers: application layer, transport layer, network layer, and link layer, and the last one is physical layer. Now, this is a diagram which represent in which horizontal lines represent the timer and senders send some data in the and it is received by the receiver. Now, how can we apply automata in this protocol? So we can apply automata in these three ways. Finite state model of the sender and the receiver using this protocol are very simple. In constructing these models, we assume that there is a higher level of process on one side that invokes the sender when it has data to send, and a higher level process on the other side. Now, although we won't handle this part of the process in the model we are about to build. We can note that the sender will maintain a FIFO, first in first out queue of message that is being told to send. Now, each time it is ready, it will remove and send the message at the head of sequence. Now, DFA, that is deterministic finite automata. Uh, Here is a diagrammatic representation for the sender's end, and here it is for the receiver's end. Now, application to stop and wait protocol. Another widely used protocol in the networking is stop and wait protocol. It is also called automatic repeat request, that is shortly called NARQ. This denotes this horizontal row denotes the sender side, and this denotes the receiver side. In ARQ protocol, the receiver communicates back to the sender and sends exploit. that communication to help it determine when a failure has occurred, and a message could be retransmitted. Now, DFA for given application. It's for sender's side, and this is for receiver's side. So first of all, the sender will never send a second message until it knows that the receiver has successfully delivered the data from the first one. So the input will go one by one. First of all, the receiver will receive the first message, then it will successfully deliver the data of first one, then it will send the second one. Now, if a data message is corrupted and the receiver can tell that, for example, by using checksum bits, the receiver can simply fail to check an ACK. The sender will time out and the message will be resent. These are also variants of the stop and wait protocol, in which explicit negative ACK message are sent when a message arrives corrupted. Now, application and alternating bit protocol. The alternating bit protocol doesn't add arbitrary subscript. It does, however, and add a single control bit to each data message and to each ACK. The bit will alternate values with each transmission. By convention, the receiver will flip the bit before sending an ACK. So the message that acknowledges the script of D naught will be ACK1 and vice versa. Now this diagrammatic representation denotes senders, and this one denotes the receiver's end. Alternating bit protocol. To describe the behavior of senders and receivers that exploit the new protocol requires two copies of the states that were needed for the stop and wait protocol. One copy corresponds to handling data whose control bit is 0. The other is handling data whose control bit is 1. Here both the sender and receiver are initially in waiting state.